This is a device built several years ago, constructed using parts taken from the dismantling of obsolete scientific equipment. The device generates a sine wave in the range of 2 Hz, 200 kHz with a maximum distortion of less than 0.02%, and has proven indispensable for conducting tests and checks on hi-fi audio systems. The instrument is equipped with an amplifier that allows an output power of 20 watts. It is possible, through this instrument, to perform permeability measurements on magnetic materials. It can be used to test ferrite magnetic cores at different operating frequencies. In the following photos, the positions of the various components of the instrument are indicated. Now a description of the oscillator module. In the photos, you can see the positions of the various components of the oscillator. And how the two helipots are fixed. In this case, I used a mechanism taken from another device. Here is the description of an alternative method to correctly fix the two helipot potentiometers. And other details of the oscillator.
Now we proceed with the calibration of the oscillator.
With the oscillator described earlier, we obtain a sinusoidal signal from 2 to 200 kHz with low distortion, making it an excellent laboratory tool. However, if we need to test high-frequency ferrite transformers or inverter cores, the output power from the oscillator is no longer sufficient to drive them. That's why I added an amplifier. The circuit I used employs the TDA 2020, an integrated circuit designed for hi-fi, but which has proven to be capable of working from 10 Hz to 160 kHz. In the video, the position occupied by the amplifier and the technical characteristics of the TDA 2020 integrated circuit. Now to conclude, in the photo a description of the transformers used in this generator. The transformers are used to have different output impedances and higher peak voltage, but above all to have galvanically separated voltages from the generator's electronics.
Turn your darkness into light. If you just believed in what we've got, then you would feel this paradise. This paradise. Paradise. This paradise.
The photo shows the switching relays, which are located in a completely shielded area so as not to cause problems to the oscillator. Below is a video on the measurements of the output voltages from the generator. An oscilloscope and frequency meter are used. Now let's proceed with the check and measurement on out 1. The vertical scale of the oscilloscope has been set to 5 volt per centimeter.
Paradise. It's paradise. Paradise.
The oscillator has been set in the range 2 to 20 Hz. From 2 Hz to 20 Hz the oscilloscope gives a reading of 15 volt peak to peak. The oscillator has been set in the range 20 to 200 Hz. From 20 to 200 Hz, the reading remains constant at 15 volt peak to peak. The oscillator has been set in the range 200 to 2000 Hz. Even in this range, the voltage remains constant at 15 volt peak to peak. The oscillator has been set in the range 2 kHz, 20 kHz. Even in this range, the voltage remains constant at 15 volt peak to peak. The oscillator has been set in the range 20 kHz, 200 kHz. In this range, the signal between 115 kHz and 200 kHz experienced a slight decline, dropping to 13.5 to 14 volt peak to peak. Now let's proceed with the check and measurement on out 2. We will measure the sinusoidal voltage output from the TDA 2020 amplifier. The vertical scale of the oscilloscope has been set to 5 volts per centimeter. The output voltage is regulated to an average value of 20 volts peak to peak. As can be seen, below 10 Hz the voltage drops below 5 volts peak to peak. The amplifier is not able to amplify these frequencies. The voltage remains stable at values from 16 to 20 volts peak to peak up to 110 kHz. Then drops to 13 volts peak to peak at 200 kHz. In this video, dealing with higher than normal voltages, I use a 10x oscilloscope probe, which reduces the voltage by a factor of 10. From 2 to 200 Hz, the voltage takes values between 14 and 20 volts peak to peak. Here the voltage varies from 230 to 160 volts peak to peak. From 200 to 2000 Hz, the voltage takes on an average value of 10 volts peak to peak.
Turn your darkness into light. If you just believed in what we've got, then you would feel this paradise. This paradise. Paradise. This paradise.
Here the average voltage is 100 volts peak to peak. From 2000 to 20,000 Hz, the voltage takes on an average value of 26 volts peak to peak. In this case, the average voltage is 220 volts peak to peak. From 20 kHz to 200 kHz, the voltage takes values between 24 and 20 volts peak to peak, with a maximum value of 60 volts peak to peak at a frequency of 133 kHz. The voltage varies from 240 volts to 500 volts peak to peak. After 130 kHz it decreases until reaching 100 volts peak to peak at 200 kHz. If you found the video interesting, leave a like and subscribe to the channel. Thank you for your attention. To the next.